Hi guys, we're back with the Unity VFX procedural VFX project, and well, as you can see, I have already created a new project called Procedural VFX, and I created it was of the type of the universal rendering pipeline type. Okay, I that comes with a sample scene, some URP. URP stands for Universal Render Pipeline Settings, and some scripts and so on. Okay, so we're gonna get rid of most of this. We don't want any of these, the presets, audio. We're not gonna be doing audio, so we're gonna get rid of all these. And the tutorial info, and even the readme, and the low, medium, and high quality. We're gonna leave only the high quality for the time being. Okay, and we're gonna call this URP settings. Okay, so we create a new scene, don't save, there we go. So we are gonna create a folder called scenes, another one called code, and another one called art. Okay, because I like to have these folders, the scenes, the code, the art. Maybe we'll have another one called prefabs, I don't know. Then what else? So we're gonna be needing, so let's just start in here. We're gonna create a code, a script, but instead of doing a normal script where we just that's gonna be executed in when we run the game, instead what we're gonna be doing is adding a script that's gonna be a tool, so something that we're gonna be using in the editor. So we're gonna call this wire sphere tool, for instance. Yeah, why not? We're gonna open it. And okay. So this tool helps the user generate a wire mesh that follows a path around a sphere. So instead of having, it's not going to be a mono behavior. We're going to be needing the Unity editor namespace, and we're going to be probably, it's going to be something like an editor window, I think. An editor window, no. So let's see. When you have doubts about it, it's best check the the help. So basically, create an editor window, custom editor window that can float and be docked. That's exactly what we need. We want a window that can be docked that we can use. That's great. So we got an editor window, and instead of that, like, so what we're going to be doing here is we are going to have a static method that we're going to put a property on top. We'll explain what's not property, an attribute to the method. So it appears in the menu, and on GUI to show whatever controls we want for this window. So we'll start with the on GUI. So so the controls for this window. So in this case, we probably want to know. Well, we can define the attributes here. Actually, we don't need public and private attributes because they are going to be private. Well, let's put one attribute and let's put it here. So radius, which is going to be, I don't know, by default, let's put it at 10. Is editor, layout, float field. I would say like sphere radius, radius, and that's about it. And then we're gonna add a another a button so that we can quit the editor tool. Sorry, the tool window. Editor window. So in order to do that, we're gonna be doing a group begin horizontal, editor, layout, and horizontal. I like to add these brackets here, but they are definitely not necessary. And then if button generate wire sphere, and then here we're gonna add a method to do that. So we're gonna be so we generate a mesh for the wire sphere with the parameters in the object. We don't have it working. We don't have anything there yet. We add another button. We add layout button exit, which basically just closes the window. There's a there's another function, as we said before, that we have to create, which is going to be a private static void. So window, which is going to be we can do editor, no, wire sphere tool, Window is editor window, create window, wire sphere tool. Let's call it like this. We could here define some things like the minimum size or something like that. I want it to be like 400 at least, and probably 305, I don't know. And yeah, this is a static method and it's not going to be called anywhere. I mean, it's actually private. This is not being used anywhere. But I'm not sure if private works. I think so. We can add an attribute to the method so that it is actually the callback or the function that is called when clicking on a menu option. So menu item, and we say things like tools, wire sphere tool. So with these, there should be a new menu in Unity, which is called tools, and then have an option here called wire sphere tool. And when we click on that, we should call this method, which basically creates a new wire sphere tool window, and it runs on its own. Well, let's see if this very basic structure works. It's compiling, and here you go. There you go. Let's see the console. Yeah, it's clean. And tools, wire sphere tool. A new window is created, which has the minimum size like that. And there we go. We got the sphere radius, which we can change, and the two options. This does nothing, and this closes the tool. Good. That's great. One thing you would notice is that if we change this and exit and then open it again, it's still 10. In my experience, it's quite useful if whatever values you leave here, you keep them for the next time, particularly within the same session. I mean, maybe it's a bit overdoing things if you want these values to be stored and remembered the next time you open Unity, but it's definitely something easy to do and desirable, that if you change values here, those values will be kept in the next time you open the tool. There are various ways of doing this, but the simplest one is just making these values static. Since they are static, they don't belong to the concrete window that you just open. They are part of the class. They're not part of the object, but of the class. So if we just do that, close it and run it again, then then we put 15 and then exit, and we open it again, it's 15 again, which is good. It's something that it's actually something we probably want. So great. If we change the code, by the way, now, since we're going to be doing it now, like let's say for instance that we add a separator, like some room and even some room here, just to make the window a little bit more appealing, and now we run the window again, this value is reset because the class is recompiled, and that means that the static values are resetted. Anyway, that's good. We have this. Great. Let's think about what we need. So we want something that goes around the sphere doing circles at different heights. Basically, those heights are not actually heights, but there are different angles of with regards to the center of the sphere. So if we think about the points in spherical coordinates rather than in Euclidean coordinates, what we see is that the radius is going to be fixed because they are at the same distance from the sphere, so that is not something we want. They're not going to be changing, or we're not going to be varying. And then we're going to be having like a given angle, say starting 80 degrees, whatever, 75 degrees. And at that angle, we're gonna go for the pitch, and then we're gonna be doing all the yaw, or almost all the yaw. We're gonna go step by step doing almost all the yaw, and then we go down, and then we go to 60 degrees, and repeat. We go down again, 45, 30, 15, 0, and then minus 15, minus 30, minus 45, minus 60, minus 75. So basically that we're gonna be having like two nested loops, yeah. So in order to do that, we need to know what are the steps that we're gonna have to be taken. Like the first, so from the first angle, so minus 75, 75 or whatever, to the final angle, which should be the same one, minus, if it starts in 75, it finishes in minus 75. What are the steps? How many steps do we put? Like, let's say we want 5, we want 10, we want 15. And how many steps do we take inside each circle? So, let's do that. So we need a pitch steps. Usually we want an odd number here, like 7, 9, or 11, because that way you will get a circle around the middle. So let's say 9, for instance. And then your steps is gonna be, I don't know, for instance, 16. Yeah, I think that's okay. And we also want to define max pitch angle, and we're gonna set it to 75, for instance. Okay. In order to better visualize these, we can try to draw some gizmos, but we cannot use the onDraw gizmos here. In order to render the scene, we're gonna have to register to an event that tells us when to redraw the scene, or when to draw for a redraw of the scene. There is an event for that in the scene view. There's a static event for that in the scene view, which means we can register to it when we enable the window, and we can register when we disable it. So in the onEnable, scene view, and draw before scene UI, or scene UI during a scene UI. So we can do a plus equal on scene UI, and we can define here a private void on scene UI, which is going to be a scene view parameter. Okay. In order, we have to disable it. Private void on disable, and we do the same. We just as a rule of thumb, it's a good idea to do this. So basically we first unregister in case we were already registered, which is probably not going to be the case. But anyway, we do it because if you're not registered, you lose nothing, and if you were already, for whatever reason, and you're calling on enable again, then you will not register yourself twice, which means that you're going to be called yourself twice, which is something you definitely want to avoid. And then we register again, and then on the disable we just unregister it. By the way, so yep, we're gonna be drawing things here, and in order to do that, we need to use we cannot use the gizmos class. Instead, we have to use the handle class, if I'm not mistaken. So here we can do something like handles, and we can add here, we can draw stuff here. So for instance, draw wire, draw sphere. Because there is draw wire arc, cube, disk. Well, we could actually draw disks. So let's draw a list. So let's draw a sphere with a number, with a bunch of arcs, a bunch of circles, a bunch of disks, I guess. So let's draw wire arc or disk, center, normal, from, angle, radius, and disk. It's gonna have that's what we want. So we want a center, a normal, and a radius. Okay. So for starters, we're just gonna be using the center is gonna be always the 0, 0, 0. The normal, we're gonna do it vertical normal, and the radius here. We can do actually 3 of these with different normals, so that we see the sphere sort of drawn. Yeah, this is what we get, which is cool. All right. So let's go and add the steps, the controls for the steps. It's gonna be, and we're gonna use a slider. So we're gonna be num pitch steps, and the minimum value is gonna be 3. We don't want it to be less than 3, and the maximum value, I don't know. Let's put it in 30, whatever. And the value, well, we have, that's right, the pitch steps is gonna be here, and then there we go. So we're gonna do the same for the yaw. Steps, it's gonna be yaw steps. Minimum of 4 and a maximum of 32. And the max pitch angle is going to be layout is going to be a slider, because it's going to be a float, where the minimum value is going to be so the max pitch angle. It's going to be the minimum value is going to be 0, and the maximum value is going to be 90. And with these, we can here create some circles. So for I equals 0, I less than num pitch steps, this is I. So float 1, so float angle is float t is float I divided by float num bits times minus 1. And float angle is gonna be lerp t, sorry, minus max pitch angle t. And now we have calculated, so we're gonna be so this loop is gonna be iterating over the pitch, and it's gonna be generating circles for each of these pitch angles. So the first thing we do is calculate the angle. With the angle, we are going to calculate the sine and the cosine, which are going to define our circles. So basically, we are going to be calculating the sine. So first we're going to calculate float angle rads. It's going to be math f vector rad times angle rads, and float cosine is math cos angle rads. Then we're gonna calculate with the sine and cosine. We can calculate the y position and the size of the circle to draw. So float y is gonna be the cosine times the radius. Float r, which is going to be the radius of the small circle, is going to be the sine times the radius. We're also going to do handles color. It's going to be new color. For instance, we're going to draw them in orange, red, green, blue. And then draw the circle. So basically we're going to be a draw wire disk. The center is going to be new vector 3, 0.0, y 0.0. The normal is going to be 0.0, 1.0, 0.0, and the radius is going to be r. And with these, we should have a well, seems to be working, but only up to a certain point. So we're only getting 1, 2, 3, 4, and maybe 5, but no more. So, well, something is wrong here. Yeah, I think I can see what. So since we're already doing this, we can get rid of this. And here we go. Now we have this 1, 2, 3, 4. So yeah, by the way, maybe we need more steps. So 1, 2, 3, 4, 5. Anyway, one of the things that we have to do here is to fix this, because the job should be here. Also, in here, why are we not seeing any circles down here? Because there should be more. There should be at least circles around the lower part of the sphere. Why are they not? Well, the reason is because yeah, when we're using the cosine of the angle, yeah, I think I made a mistake. This should be the radius and this should be the y value. Yeah, that's correct. I made a mistake. I was considering the pitch. The pitch is the angle that goes from here up or down, and that means that this sine is this height and the cosine is how big the circle is, which is good. Now we have like this, and it kind of gives us an idea of where the wire would go. Make it bigger or smaller, make it more or less, and change the maximum angle. So I like it like this, and I like it with 9 is okay, and maybe 80. Now it's 75. I think 75 or 70 is okay. 75 seems okay to me. So yeah, that is good. That looks good. Great. Now, but it's still not doing anything. So we need something else. We need the size of the wire as compared to the so this is going to be a wire that's going to be around these circles, right? But it's going to have some thickness. So we're going to add a float thickness, for instance. We're going to call it like thickness, and we're going to give it a 0.2 value, for instance. We can draw this simply drawing thickness circle to indicate the this is the wire. So we're gonna do handles. We could actually use different colors for these two things. So we could be, so this could be in, say, red or in yellow, and it could be draw wire disk, new vector 3. We're gonna put it at the R, Y 0.0. We're gonna give it a normal of 0.0, 0.0, 1.0, and the radius is gonna be thickness. So this should add some circles area, and gives us an idea of how big the wire would be. We could we should add it here, like thickness is editor or layout. We have a slider here. Thickness, that would be thickness would be a 0.0 or 1.0, for instance. And yeah, so yeah, this is too big, obviously, and maybe we want a 0.1 or 0.125. I don't know. Yeah, something like this feels appropriate, because we want a wire. We don't want something thick, something big. It's just a small wire that goes around. Great. So good. We have already I think we have all the parameters we need. Now it's time to generate the geometry. How are we gonna be? So I think this video is getting a bit too long, so I'm gonna stop here, and because we have already set up the the tool, and the next step is to generate the geometry from this, which is gonna be a complex subject on its own. So I'm gonna stop here, and I'll go on from here in the next video. Thank you for watching, and if you like it, please click the like button, and if there's anything, any doubts or whatever you want to ask me, feel free to write them in the comments below. See you in the next video. Bye.